Hello, my name is Carson Sierra, and I'll be presenting my independent lab about measured heat resistance of different socks. Quick overview, I will discuss why I chose this project, how I went about doing the measurements, my results, and the conclusion. So, I live in Fairbanks currently, where it can get to negative 40 degrees Celsius, which means I can get cold feet. Over time, I've collected many different types of socks to keep my feet warm, and I was curious what the difference between the socks were. Were there some socks that would hold heat better than others? I don't know, and this felt like the perfect project to do that. So here's a picture of one of my setups. As you can see, I have socks, and inside of them are water bottles. I'll go over that in a little bit. And the sensor is in between the sock and the water bottle. But for the procedure, I would fill up the water bottle with hot water, put it inside the sock, put in the sensor, and let it cool down. Now it was important to put these on insulated pads because the table could suck heat. I wanted to make sure it was away from any wind or airflow or the window, try to keep this as stable of a room as possible. So here is the sensor that I used. I used a surfaced thermistor. I had 3 different ones total, and they have an error of plus or minus half of a degree Celsius. So my first try, I used an aluminum can with boiling water. That was really difficult to put the sock around and pour boiling water. I might have burned myself a little bit trying that. So instead I switched to plastic water bottles and hot water from the tap. That seemed to be just perfect. I would fill up the water bottle, put it in the sock, and put the sensor in the sock and let it run. Now, here is just an example of the raw data collected from test 6. The important thing to observe about this graph is just the little variance of the temperature as it goes down, but overall you can see this nice curve. And here, these two temperatures are just showing the room temperature read by sensor 2 and sensor 3. Just really showing that each temperature had its own amount of error preset. So now we have all of this data. How can we determine the different rates of change of this? And I just simply use this equation. It's Newton's law of cooling. The important thing to look at is I just solved for this value k. This value k gives sort of the characteristics of the different socks and what I use to compare each sock. Here's an example of that k value. From the earlier data I showed, I just grabbed a temperature from on the line, the atmospheric temperature, and the initial temperature. I did all the calculations at the time and had a really nice fit to the actual data, which was really exciting. The red line is the model temperature and the blue line is the raw data. So I did that for every single test that I had for each sock, and I was able to get each sock's individual K value. And here I plotted all of those socks starting from 37 degrees Celsius down to 22 degrees Celsius. Now again, I used a calculated K value for each of these socks, as well as the control bottle and control can, where those were just a bottle in the can without any sock around it, just to see how quickly it would cool. And as you can see down here, the bottle in the can had cooled much quicker, sooner. Here's a smaller graph to really show the control can down here, and then all the other socks up here. So this graph is a little bit different than the last one. It is showing at each of these temperatures what the amount of heat loss, which was degrees Celsius per minute, each sock would experience at that temperature. So let's say at 37 degrees Celsius, we would see that the bottle and the can would be losing more degrees Celsius per minute than the other sock. And here's just a bar graph showing the same thing. Here the controls are showing This time it's in Fahrenheit that they are losing the same amount of heat, or losing a lot amount of heat compared to the wool socks. So one of the things to consider is the uncertainty of this experiment. Uh, Unfortunately, all the sensors I used had different room temperature readings, which meant that I needed to calculate the value of K specifically for each sensor. There was some airflow in my dorm that could have affected more cooling than would be usual without air. And the samples of the socks, there are different thicknesses in the socks. Some socks have taller ankle lengths, which could hold in more heat potentially. And there's much more criteria that needs to be accounted for to make more conclusive results. And I don't believe that the results I had gotten from this experiment are conclusive enough to tell me exactly what type of sock I should wear if I don't want to get cold. So again, in conclusion, I took a bunch of socks, I put a hot water bottle in them and saw how quickly those cooled. I found the independent value associated with each sock and compared them to each other, and the results were semi-inconclusive. It was the main thing we can conclude was that the control bottle lost more heat than when it had a sock on it, which makes sense. But in order to get a better in order to get a better idea of what sock would be better, I would need to do more tests of the socks and control the environments a little bit more and use the same sensor. So thank you for listening to my presentation. Have a good day.